Hello, here are some brief images of some of the modifications to the 4.5 megahertz Tesla coil that I've used to make a plasma speaker. But this time it is not set up as a plasma speaker, but I have made some modifications to the resonator that allow the changing of coupling between the primary and the secondary. And you can see inside where I have inserted the primary coil inside of the secondary tube, and it can be manipulated by means of this fiberglass rod, which allows me to rotate the coil, the primary coil, inside of the secondary. This allows an extra degree of freedom in tuning the coil for maximum power output and minimum heating of the final power amplifier transistor here. I also have the shunt tuning capacitor in place, which allows the degree of freedom that I've used in the past. But with the combination of the coupling and the tuning capacitor, I can achieve significantly higher powers than just using the capacitor alone. So if we switch on the power supply for the final power amplifier, we immediately see the brush discharge at the top of the coil. The coil has been adjusted for as much power as possible for the given DC power input. But we see here, if we look at the drain voltage on the oscilloscope, it is behaving a little bit unstably. And this is generally because there's a little too much coupling. And also there are dynamics involved with the phase locked loop, which I won't go into here. But by modifying the coupling a tiny bit, I have removed the instability. But you see that despite that, there is still a bit of movement in the trace as a result of the chaotic behavior of the brush discharge. Here we have achieved a fairly close match, which allows us to get close to zero voltage switching. If we modify a little bit the capacitance, we can improve things a little more. Okay. And we see our discharge. Now we can switch the power off and see how hot our transistor has got. It's still cool enough to touch. That is a good sign.